Hi everyone, this is Rakshita BK studying at Sri Venkateshwara College of Engineering. Today I am going to discuss about the applications of vector calculus in electronics and communication engineering. Now I am going to discuss about the vector calculus, applications of vector calculus in electronics and communication engineering, electromagnetics, signal processing, antenna design, circuit analysis, wave propagation. Introduction. Vector calculus is a field of mathematics that deals with a vector field, which are functions that assigns a vector to each point in space. It combines the concepts of calculus, a vector to each point in space. It combines the concepts of calculus and linear algebra to study properties such as differentiation and integrations of vector functions. In vector calculus, you will encounter various important concepts like gradient, divergence, curl, line, integrals, surface integrals, and volume integrals. These concepts helps you analyze and solve problems related to motion, forces, fluid flow, and electromagnetism. To name a few, vector calculus has wide-ranging applications in physics, engineering, computer graphics, and many other fields. It's a fascinating subject that allows us to understand and describe the behavior of vector in three-dimensional. Now, let me see what is vector calculus. Vector calculus is simply the study of vector fields differentiation and integration. It's a core branch in calculus that covers all key concepts to master differentiating and integrating all kinds of vector functioning. In vector calculus, we'll expose the following: mastering the fundamentals of vector quantities, understanding how vector valid functions behaves in 2D and 3D coordinate systems, evaluate signal and even multiple integrals of vector valid functions, learning how to integrate vector fields and important techniques in higher physics. Will being our discussions by defining vectors. These are quantities with both length and directions, normally represented by arrow. Now we'll see the applications of vector calculus. It is used extensively in physics and engineering, especially in the description of electromagnetic fields, gravitational fields, and fluid flow. Vector calculus is used in geodesics on a surface, electric field from distributed charge, floating a slice of a vector field to find the rate of change of the mass of a fluid flow. In rigid body dynamics, in rectilinear and plane curvilinear motion along paths, and in both rectangular. Applications of vector calculus in electronics and communication engineering. Vector calculus has numerous applications in the field of electronics and communication engineering, electromagnetics, signal processing, circuit theory, communication system, control system. Electromagnetics. Electromagnetics. Vector calculus plays a crucial role in understanding and solving electromagnetic problems. It helps in analyzing electric and magnetic fields as well as in studying phenomena like wave propagation, antenna design, and circuit analysis. Antenna design. Antenna design. Antennas are a fundamental component of communication systems. Vector calculus is employed to analyze radiation patterns, antenna gain, and beamforming techniques. It helps engineers optimize antenna design for efficient transmission and reception of signals. Signal processing. Signal processing. Vector calculus techniques such as Fourier transform and Laplace transforms are extensively used in signal processing applications. These transforms helps in analyzing and manipulating signals, allowing for tasks like filtering, modulation, and demodulation of electronic signals. Transmission line analysis. Transmission line analysis in electronic circuits and communication systems. Transmission lines are used for the efficient transforms of signals. Vector calculus is employed to analyze the behavior of signals along transmission lines, including impedance matching, signal reflection, and transmission line termination. Now let me see the applications of vector calculus in wave propagation. Wave propagation. Understanding how waves propagate through different media is crucial in communication engineering. Vector calculus helps in studying the characteristics of wave propagation, including wave equation, polarization, and propagation constants. These are just few examples of how vector calculus is applied in electronics and communication engineering. It's a powerful tool that allows engineers to understand and optimize various aspects of electronic system and communication. Now let me see the conclusions of vector calculus in electronics and communication engineering. Vector calculus deals with vector fields, which are functions that assign a vector to each point in space. Some key concepts in vector calculus include gradient, how gradient is going to work, in applications of electronics and communication engineering, divergence, curl, line integrals, and surface integrals, and differentiation of integrals. The gradient of a scalar field represents the direction and magnitude of the steepest increase to the field. Divergence explains how it measures the rate at which a vector field spreads or measures the rate at which a vector field spreads or converges at a particular point in space. Curl describes the rotation or circulation of a vector field around a point. Line integrals involve calculating the total effect, how it is going to calculate the total effect in applications of vector calculus and of a vector field along a curve, while surface integrals deal with calculating effects over a surface. Thank you.